We want to solve cosecant of 5x equal negative square root of 2, finding exact solutions on the interval from 0 to 2 pi. Well, I know exact values on the unit circle for sines and cosines, so I'm going to take the reciprocal of both sides of this equation. 1 over cosecant 5x would be sine of 5x, and that's going to equal, the reciprocal here is going to be 1 over square root 2 with a negative on it there. And that may not be recognizable to you from the unit circle, but if I rationalize this, you'll recognize it. So this is going to be negative square root 2 over 2. So now I think about the unit circle and I think what quadrants would have a negative sign value, and I'm looking for negative square root 2 over 2. So I know they're multiples of pi fourths that are in quadrants 3 and 4. So I'm going to think of this angle as theta for just a minute, and we found out that theta equaled in quadrant 3, that's 5 pi fourths, and to get all angles that would be plus 2 pi k, just loops around the circle there, right, getting all angles. And the other angle, the one in quadrant 4, is 7 pi fourths plus 2 pi k. But we have 5x, not theta, and we want to solve for x. So I can put this equal to 5x, and I can put this one equal to 5x. And now what I'm going to do is I'm going to divide everything by 5 so that we can find out what x equals. And so I need to divide both terms on this other side by 5, and let's do that everywhere here. And now I have an equation, x equals, and I can generate all solutions. Now I'm only interested in the solutions on the interval from 0 to 2 pi. Okay, so now I'm ready to find out what x equals, listing these solutions. So the first solution is going to come from letting k be 0 here, and we have 5 pi over 20, but that'll reduce down to pi over 4. We're going to get another solution by looking at the second equation, and 7 pi over 20. Now, normally, if we would have just had sine x equals something, on the interval from 0 to 2 pi here, we would have had two solutions. But we didn't have x, we had 5x, and so we'll have 5 times as many solutions. And so instead of 2, we need to find 10 solutions. So to get a third solution, we're going to take the pi fourths and we're going to add a period to it. And a period is right here, a period is 2 pi fifths. Well, we need to get a common denominator, so this first one was 5 pi 20ths, and we are going to add to that 2 pi fifths, but we're going to convert it to 20ths by multiplying top and bottom by 4, so that's going to be 8 pi 20ths to add a period to that. So 5 pi 20ths plus 8 pi 20ths is 13 pi 20ths, and that's another of our solutions. And now we're going to find another one by adding a period onto 7 pi 20ths. So 7 pi 20ths plus a period of 8 pi 20ths will give us 15 pi 20ths. And actually, that one we could reduce that by 5 each to 3 pi fourths. Okay, then I'm going to add another period onto 13 pi 20ths to get another solution. 13 pi 20ths plus 8 pi 20ths is 21 pi 20ths. And I'm going to find another solution by taking 15 pi 20ths and adding the period of 8 pi 20ths. That will be 23 pi 20ths. I'm going to continue this for 21 pi 20ths, adding 8 pi 20ths, I'll have 29 pi 20ths, and adding 8 pi 20ths to 23 pi 20ths, that will give me 31 pi 20ths. And you see I'm still on that interval from 0 to 2 pi by the time I had divided by that 5, so that's why I need to keep going and listing all solutions on that interval. I'm now going to add 8 pi 20ths to 29 pi 20ths, and I'm going to put it above because I'm pretty much out of room, so the other two are going to be continued up here. So 8 pi 20ths to 29 pi 20ths will give me 37 pi 20ths. And then I'm going to add 8 pi 20ths to 31 pi 20ths, and that will give me 39 pi 20ths. Now let's say we weren't paying much attention and we didn't realize we already had 10. If I added 8 pi 20ths to 37 pi 20ths, I'd get 45 pi 20ths. Well, that's past 2 pi because 40 pi 20ths is 2 pi. So that is outside of our interval. And here are the 10 solutions that solve the equation cosecant of 5x equal negative square root of 2 on that interval from 0 to 2 pi.